Okay, in this question, we are given that the mass is 2 kg and the time of heating is 40 seconds and the power, which is joules per second, is 100. And this is equivalent to 100 watt. And the specific heat capacity of copper is 400 joules per kg per Kelvin. Okay, so we want to find out what is the rise in the temperature. Okay, we can use the formula. Heat energy is equal to mc theta, and theta is the rise in temperature. And to find the heat energy, we can use the formula power times time. So power times time is equal to mc theta, and theta is equal to power times time divided by the mass and the specific heat capacity. So we will get 100 multiplied by 40 divided by 2 divided by 400. So in this case, we will get the answer as 5 Kelvin, and the answer will be A. Okay, we have 4 bars of different material being placed into boiling water, and the time for them to rise by 2 degrees Celsius are recorded here. Okay, now let's look at aluminium and copper. Aluminium takes 10 seconds and copper takes 5 seconds. That means that the copper conducts heat very well. So the copper is a good conductor of heat, and the aluminium is a poorer conductor of heat compared to copper. And whereas for cork and styrofoam, cork takes a shorter time than styrofoam to rise by 2 degrees Celsius. So that means if you just to compare between these two, the styrofoam is a poorer conductor of heat than cork. Okay, so now we want to make a metal tank with the least heat loss. So which material should be used by the tank? And its insulation. So if you want it to prevent heat loss, right, we should choose the material that are poorer in terms of conducting heat. So that will be aluminium as well as styrofoam. So the answer will be B. We have 4 metal cans here, and each of them holds 100 cubic centimeter of water at 70 degrees Celsius, and they are made of different color and different texture. So we are asked which can cools the most rapidly. Okay, in order for them to cool the most rapidly, right, we are looking at the best emitter of radiant heat. Okay, and a good emitter of radiant heat, right, it has to be black in color and it has to be rough in the surface. So in this case, the answer should be A. In this question, we are asked how can we calculate the wavelength of a wave. Okay, so we can use the wave equation. V is equal to F lambda. So the wavelength is actually equal to the speed divided by the frequency. If you look through the 4 options, you cannot find the speed divided by the frequency. So what we can do is that we can represent frequency in terms of period. As we all know, frequency is equal to 1 over period. So V over F, it is also equal to V divided by 1 over T, and that will give us the V multiplied by T. Okay, so we can see the wavelength as the speed multiplied by the period. Okay, so the answer should be D. This is a periscope. So we have an object here, and the light from the object, it will travel in this direction and it will hit the mirror. This is the normal, and it will be reflected downwards, and we have draw another normal. It will be reflected the second time into the eye of the observer. Okay, the eye only see this part of the ray. The eye doesn't know that the ray has taken one band here and another band here. So what the eye do, right? The eye will trace back along this path to locate the image. So how long will it trace back? It is the same as the distance traveled by the light ray. So the light ray travel this distance, and this distance. So you add these three distance up, and the eyes will trace back the same distance to form the virtual image at